All right, in this video, I'm breaking out the Hocking Phasec 3D old school tester, typically used in aircraft. Nick Cardillo from Z-Tech was nice enough to loan me this GE rotary scanner because my mini-mite does not work with the Phasec 3D. And of course, I got my trusty fastener hole cow block from the UK, which is probably where this scanner came from. And, just checking out the Phasec. I haven't used this particular tester much. But again, this video just shows you that, you got an old tester. Sometimes it still may do the trick. So what we have here, when you want to calibrate noise and stuff, you can just put your probe down like that. You can already see that I've got the noise pretty much horizontal. Now I got a question for all you Hocking guys. When I go in the hole, well, that's pretty darn centered. How do I move this back and forth? I tried to find the button for that, but I don't need to adjust it now because it's pretty much kind of out there in the middle of my display. So I have a series of holes here, and there's a full depth notch. You can probably see it. Wait, I can't even see it. Where the heck is it? Again, I got to blame the AV guy. He's not working today. Anyway, on one side of each hole is a full depth notch, and I can go in one of the bigger holes and just focus on keeping my coil on the side of the hole with no notch. And if I slowly move around the other side of the big hole, voila! It's like Paul Holloway says from Canada, UT extraordinaire. He said, you learned a lot about NET and Sesame Street. Which one of these things is not like the other? If you go in a bunch of fastener holes and you get that, then you go to another hole and you get that, then you go to another hole and you get that, and then finally you go to another hole and you get that. Wow, that's different. Obviously, something's going on with that. Now, if you test hundreds of these holes and you only get one or two that look radically different from the others, that's obviously a point of concern. So I don't work in aviation, but I don't know what the process would be. I guess you tell your boss, and he probably wants to try to confirm it with something else, maybe retest it. Always a good idea to test it with a little bit of higher speed and a little bit lower speed. Now, this is a big old notch. I'm going to see if I can figure out with this tester how in the heck to change my RPM. I know it's pretty darn easy. It must be this exec button. No. That button. No. That button. Anyway, it doesn't really matter because changing the RPM is not going to do a ton. There it is right there. All right. I was only operating the probe at 600 because I don't want to burn up Nick's probe. Not that that would by running at a high RPM, but we're going to crank it up to like 3,000. Well, obviously that changes our amplitude of our noise a bit, huh? Now, what's the advantage of going with a higher speed? Well, if you're indexing the probe in by hand manually and you're being careful to index at the same speed, you'll get more. Your pitch will be less. What that means is for every rotation, you'll get a lot more scans per index unit going forward, if that makes any sense to you. So higher scanning speed, if you keep your indexing the same, you'll get more coverage, which will give you more resolution. Okay, so now I'm going to go back down to 600. Now this baby's got so much momentum, it takes a while for it to slow down. But see how that brings the noise down? And again, let's see, what are some of the other settings in here? No, I don't want that one. What I want is, no, 600. I got to get better at figuring out where these menus are at. Let's see here. The high pass filters. Where's the high pass filter? Oh, I just passed it. There it is, and I want the RPM to go down. But for the high pass filters and low pass, what I basically did was when I had this cow block, and you got to hit this exec button to go from high pass to low pass. But really you can just start tweaking your filter settings. Nah, it don't look good. I'll go back the other way. Until you can get this signal from your flaw to be more pronounced. You always have to remember that when adjusting high pass filters, they're speed dependent. So if you have your RPM set and your high pass filter set where you can see a flaw, you have to be careful if you change the RPMs or your indexing speed. If you do that without resetting your high pass filter and checking your cal standard, you could be shooting yourself in the foot. Because what can happen is if you adjust that high pass filter, you can attenuate the flaw portion of the signal, and that would be bad. Now the reason I'm making this video today is because I really just want to check out the Phasec 3D a little bit, because over the past weekend I made a video doing rotating scans on fastener holes with the Waygate Mentor EM, the Nortec 500, the Nortec 600, and I figured, you know what, we got to give the old Phasec 3D a fair shake. Now I did notice that with the Phasec, you get a few different options for displaying the data. Well, it's a time-based display. Okay, there's no flaw. Let me go to another hole with no flaw. Then another one. Then go back to a flaw. You know, it sticks out like a sore thumb, so you shouldn't have any problem seeing that. That's the waterfall display. There's probably some settings in here where I can make that a little more, probably store more rotational lines. Here it's only, give me a couple. Trace record, no. Anyway, hey, I just started using this tester. You can't expect me to know every feature. So there's the waterfall. Here we got the sweep display and the Lysigue. No flaw. Then we've got just the Lysigue screen, named after Antoine Lysigue, the master of the Lysigue figures. Time base, waterfall. All right, so yeah, that's a pretty cool little machine. You know, it still works. Oh, sorry, Chuck Hellier would have my head. It's not a machine, it's a test instrument, a device of precision. And this video shows you that, again, I never used this tester, but if you are skillful at using all the features of your test instrument, you'll pretty much realize that all of the testers have common features. For doing this rotating scanning, of course, you've got your gain, and then you've got your RPMs, and then you've got your high pass and low pass filters. And you know what was different about this particular instrument was that, you know, I had to figure out how to manipulate the menus, and there's this little execute button that you have to hit to go back and forth between, like, if you're adjusting your display, X direction, Y direction, or when you're adjusting your gain, you had to hit that execute button to go between vertical and horizontal gain. So again, it's really more about learning the menus and where all the different buttons and controls are when you use a different tester. But you should always be able to, you know, if you show up on a job site and your favorite tester's not there and your boss said, here, use the Phasec or the Nortec or the Z-Tech or whatever it is, or the Roman. What else is there out there? Ether NDE, Unuest, I may be forgetting some folks, but you know, there's a lot of companies out there that make testers, and there's a lot of good testers out there. Some are a little bit easier to use than others, you know, and most of them have features that you won't probably always use. You'll use the basics, but it's like Microsoft Word or Excel, you know, there's 10,000 features in there. But you use the ones that are important, like set noise horizontal, balance, make sure your drive voltage and gain is correct, high pass, low pass filters. Obviously the colors, you can see I'm using green. I like to use green. Anyway, I'm gonna have to take a little bit better video of the Phasec, and then I'm gonna have to edit it in with my video that has the 3 or 4 other testers for rotating scanners. All right, hope you enjoyed the video. Have a good day.